ಹಲೋ. ಹಾ, ಕೇಳ್ತದ. ಓಕೆ, ಓಕೆ. ಬಾಕಿಯವ್ರು ಬರ್ಬೇಕಷ್ಟೇ ಅಂತ. ಲಾಸ್ಟ್ ವೀಕ್ ಕಮ್ಮಿ ಇದ್ರು ಜನ. ಹಾ, ಮಾಡಿದ್ದೆ. ಸ್ಟಾರ್ಟಿಂಗ್ ಅದೇ ಎಂಥೂಸಿಯಾಸಮ್ ಇರ್ತದೆ, ಮತ್ತೆ ಲಾಸ್ಟಿಗೆ ಇಬ್ರು 3 ಜನ ಇರ್ತಾರೆ ಅಷ್ಟೇ. ಅದು ರೆಗ್ಯುಲರ್. ಅದ್ ಮಾಡಿದೆ, ಅದು ವಾಪಸ್ ರಿವಿಷನ್ ತಗೊಳ್ತೆ. ಯಾಕಂದ್ರೆ ನಾನು ಲಾಸ್ಟ್ ವೀಕ್ ರೆಕಾರ್ಡ್ ಮಾಡ್ಲಿಲ್ಲ, ನಾನು ಊರಲ್ಲಿದ್ದೆ. ಹಾಗೆ ಅದಕ್ಕೆ ಹೋಗ್ಲಿಲ್ಲ ನಾನು ಲಾಸ್ಟ್ ವೀಕ್. ಸ್ಕ್ರೀನ್ ಕಾಣಿಸ್ತದಲ್ಲ? ಓಕೆ, ಓಕೆ. ಲಾಸ್ಟ್ ವೀಕ್ ಅದೀಗ ವಾಪಸ್ ತಗೊಳ್ತದಾನೆ ಅದನ್ನೇ. ಬಟ್ ಈಗ ಇವತ್ತೊಂಚೂರು ಜಾಸ್ತಿ ಕಂಟೆಂಟ್ ಹಾಕಿದ್ದಾನೆ ನಾನು. ಲಾಸ್ಟ್ ವೀಕ್ ಬರೀ ಅದೇ ಲಾಸ್ಟ್ ವೀಕ್ ನಾನು ಬರೀ ಯಾವುದು ಇಲ್ಲಿ ಇದನ್ನು ತೋರಿಸಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೆ ನಾನು ಅವರಿಗೆ. ಬಟ್ ಇವತ್ತು ಒಂಚೂರು ಅಂದ್ರೆ ಇನ್ ಡೆಪ್ತ್ ಆಗಿ ಎಕ್ಸಸೈಸ್ ಇದೆ ಇದೆಲ್ಲ. ಸೊ ಎಕ್ಸಸೈಸ್ ಮಾಡುವಾಗ ಕರೆಕ್ಟಾಗಿ ಅರ್ಥ ಆಗ್ತದೆ ಅಂತೇಳಿ, ಮತ್ತೆ ಒಂಚೂರು ಲೈವ್ ಕೋಡಿಂಗ್ ಅಲ್ಲೇ ನೋಡು ಅಂತೇಳಿ. ಅದೇ ಕಂಟೆಂಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಎಫರ್ಟ್ ಬೀಳ್ತದೆ ತುಂಬಾ. ಈಗ ಊರಿಗೆ ಹೋದ್ರೆ ತುಂಬಾ ಕಷ್ಟ ಆಗ್ತದೆ ಅದೆಲ್ಲ ಮಾಡೋದು. ಹಾ, ಕಸಿನ್ ಮದುವೆ ಇತ್ತು ಲಾಸ್ಟ್ ವೀಕ್. ಹಾ, ಇದ್ರತಾ ಪುತ್ತೂರಿತಾ? ಹಾ, ಬಪ್ಪನಾಣಿದ ನೋಡಿದೆ. ಅದೇ ರಥ ಏನೋ ಇದಾಗಿತ್ತಲ್ಲ. ಹ್ಮ್ ಹ್ಮ್ ಹ್ಮ್. ಹಾ ಹ್ಮ್ ಹ್ಮ್ ಹ್ಮ್. ಅದು ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಅಂತ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿರ್ತಾರೆ. ಇದಾಗಿದ. ಹಾ 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 ಹಾ. ಹ್ಮ್ ಹ್ಮ್ ಹ್ಮ್. ಹಾ 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 ಹಾ. ಹ್ಮ್. ಅಲ್ವಾ, ಲೈಟಾಗಿ ತಿನ್ಲಿಕ್ಕೆ ಎಂತ ಉಂಟು ಅಂತ ಕೇಳಿದ್ದು. ಮಿಸ್ ಸರ್. ಹ್ಮ್ ಹ್ಮ್. ಓ, ನಿಮ್ದ್ರಲ್ಲಿ ಏನಾದ್ರು ಮುಂದೆ ಹೋಗಿದಾರೆ ಈಗ ಡಿಜಿಟಲ್ ಟ್ಯೂನಿಗೆ? ಆಲ್ಟರ್ನವ್ರು ಕಾಸ್ಟ್ಲಿ ಜಾಸ್ತಿ ಮಾಡ್ತಾರೆ ಅಷ್ಟೇ. ಅವ್ರದ್ದು ಎಂತ ಟೂಲ್ ಮಾತ್ರ, ಅವ್ರು ಏನು ಇನ್ ಡೆಪ್ತ್ ಹೋಗುದಿಲ್ಲ ಅವರು. ಅದೇ ಅದೇ. ಹ್ಮ್ ಹ್ಮ್ ಹ್ಮ್. ಅದ ಅಲ್ಲ, ಅವ್ರದ್ದು ಅಷ್ಟು ಇನ್ ಡೆಪ್ತ್ ಇಲ್ಲ ಅವರು. ಮತ್ತೆ ಇನ್ನೊಂದಂತ ತುಂಬಾ ಚಾರ್ಜ್. ನಮ್ಮ ಹತ್ರ ಇಲ್ಲಿ ಆಲ್ಟರ್ನವ್ರು ಬರ್ತಾರಲ್ಲ, ನಾವು ಕ್ರಾಸ್ ಕ್ವಶನ್ ಮಾಡಾಗ ಮತ್ತೆ ವಾಪಸ್ ಹೋಗ್ತಾರೆ ಅವರು. ನಾವಂದ್ರೆ ತುಂಬಾ ಕ್ವಶನ್ ಮಾಡ್ತೇವೆ, ಮತ್ತೆ ವಾಪಸ್ ಹೋಗ್ತಾರೆ ಅವರು. ಇಲ್ಲ, ನಮ್ಮ ಹತ್ರ ಫೀಚರ್ ಇಲ್ಲ ಅಂತೇಳಿ. ಹ್ಮ್ 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 ಹ್ಮ್. ಅಲ್ಲ, ಯಾಕಂದ್ರೆ ಪ್ರತಿಯೊಂದು ಪ್ರಾಡಕ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಬೇರೆ ಬೇರೆ ಇರ್ತದೆ. ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಇದನ್ನು ಜನರಲೈಸ್ ನಮಗೆ ಸಾಫ್ಟ್ವೇರ್ ಡೆವಲಪ್ಮೆಂಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಅಂದ್ರೆ ಬೇಸಿಕ್ಗೆ ಮಾಡ್ಬೋದು ಅಷ್ಟೇ. ಬಾಕಿ ಫೈನ್ ಟ್ಯೂನಿಂಗ್ಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಅಡ್ರೆಸ್ ಮಾಡ್ಬೇಕು ಅಂದ್ರೆ ಅವ್ರದೇ ಇನ್ಬಿಲ್ಟ್ ಇನ್ ಹೌಸ್ ಮಾಡ್ಬೇಕಾಗ್ತದೆ. ಒಂದೊಂದು ಪ್ರಾಡಕ್ಟಿಗೆ ವೇರಿ ಆಗ್ತದೆ ಅದು. ಯಾರು ಜಾಯ್ನ್ ಆಗೋದೇ ಕಾಣೋದಿಲ್ಲ. ಆನ್ ಟೈಮ್ ಇಲ್ಲ. ಮತ್ತೆ ಊಟ ಮಾಡ್ಬೇಕಷ್ಟೇ ಈಗ. ಊಟ ಮಾಡ್ಲಿಕ್ಕೆ ಇನ್ನ ಆಗ್ತಾ ಉಂಟಷ್ಟೇ. ಲೇಟ್ ಆಯ್ತು. ಶನಿವಾರ ಒಂದು ಮತ್ತೆ ನಾನು ಕಂಟಿನ್ಯೂಸ್ ಇದು ಈಗ ಸಾಯಂಕಾಲದಿಂದ ಇದ್ರ ಮೇಲೆ ಕಂಟೆಂಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ರೆಡಿ ಮಾಡ್ತಿದ್ದೆ ನಾನು. ಹಾಗೆ ಟೈಮ್ ಆಯ್ತು ಅದು. ನಿನ್ ಬೇಕಾದ್ರೆ ಊಟ ಮಾಡ್ಕೊಂಡು ಬಾ, ನಾನು ಬೇಕಾದ್ರೆ ಮತ್ತೆ ಕನೆಕ್ಟ್ ಮಾಡ್ಬೋದು. ಆಯ್ತಾ? ಓಕೆ ಓಕೆ. ಪ್ರವೀಣ್ ಬಂದಿರಲ್ಲ ಲಾಸ್ಟ್ ವೀಕ್. ಅದೇ ಇಂಡಸ್ಟ್ರಿಯವ್ರು ಯಾರಾದ್ರು ಬಂದ್ರೆ ಈಸಿ ಆಗ್ತದೆ, ಯಾಕಂದ್ರೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅರ್ಥ ಮಾಡ್ಕೊಳಕ್ಕೆ ಈಸಿ ಆಗ್ತದೆ. ಅದಕ್ಕೆ ಲಾಸ್ಟ್ ನಿನ್ನೆ ಸಂದೀಪ್ ಅಂತ ಅವನ ಹತ್ರ ಮಾತಾಡ್ತಿದ್ದೆ. ಅವನು ಪುರುಷದವನು. ನಾನು ಆಕ್ಚುಲಿ ನಂಗೆ ರೆಫರೆನ್ಸ್ ಕೊಟ್ಟದ್ದು ಅವನು ಪುರುಷಕ್ಕೆ ಬರ್ಲಿಕ್ಕೆ. ನನ್ನ ಅದೇ ಬಿಟೆಕ್ ಕ್ಲಾಸ್ಮೇಟ್ ಅವ. ಹಾಗೆ ಅವ ಈಗ ಪುಣೆಯಲ್ಲಿ ಇದಕ್ಕೆ ಏನು ಪ್ರಾಡಕ್ಟ್ ಡೆವಲಪ್ಮೆಂಟ್ ಇದಾಗಿದ್ದಾನೆ, ಹೆಡ್ ಆಗಿದ್ದಾನೆ ಅವನು ಪುರುಷದಲ್ಲಿ. ಅವನು ಮಾತಾಡ್ತಿದ್ದೆ, ಅಲ್ಲಿ ಉಂಟಂತೆ ಅನಾಲಿಟಿಕ್ಸ್ ಎಲ್ಲ ಮಾಡ್ತಾರಂತ ಅವರು. ಸೊ ಅನಾಲಿಟಿಕ್ಸ್ ಮಾಡ್ತಾರಂತೆ, ಇದೆಲ್ಲ ಮಾಡ್ತಾರಂತ ಅವರು. ಬಟ್ ಅವನಿಗೆ ಅಷ್ಟು ನಾಲೆಜ್ ಇಲ್ಲ. ಸೊ ಅವರಿಂದೆಲ್ಲ ಇನ್ಸೈಟ್ ಸಿಕ್ಕಿದ್ರೆ ನಮಗೆ ಇನ್ನೂ ಅದೇ ಈಸಿ ಆಗ್ತದೆ. ಮತ್ತೆ ಅವರಿಗೆ ನಾಲೆಜ್ ಇರ್ಬೇಕು, ಯಾಕಂದ್ರೆ ಮೂವಿಂಗ್ ಫಾರ್ವರ್ಡ್ ನೋಡೋದಾದ್ರೆ ಒಬ್ಬ ಪ್ರಾಡಕ್ಟ್ ಡೆವಲಪ್ಮೆಂಟ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಅವನಿಗೆ ಇದೆಲ್ಲ ನಾಲೆಜ್ ಇದ್ರೆ ಆಗ ಮಾತ್ರ ಅಲ್ಲಿ ರಿಯಲೈಸ್ ಆಗ್ತದೆ, ಅದು ಆಕ್ಸಿಲೇಟ್ ಆಗ್ತದೆ ಪ್ರಾಡಕ್ಟ್ ಡೆವಲಪ್ಮೆಂಟ್. ಈಗ ಅವನಿಗೆ ನಾಲೆಜ್ ಇಲ್ಲ, ಸಡನ್ ಯಾವುದೋ ಬೇರೆ ಕಂಪನಿಯವ್ರು ಬಂದು ಪ್ರಪೋಸ್ ಮಾಡ್ತಾರೆ, ಅದು ಹೇಗಾಗ್ತದೆ ಅಂದ್ರೆ ಏನು ಆ, ಏನು ನಮ್ಮ ವೀಕ್ನೆಸ್ ಅಂತ ತಗೊಳ್ತಾರೆ ಅವ್ರು, ಈ ಬೇರೆ ಕಂಪನಿಯವರು. ಅಂದ್ರೆ ಈಗ ಪ್ರಾಡಕ್ಟ್ ಯಾರು ಆಲ್ಟರ್ ಅಥವಾ ಯಾರಾದ್ರು ಇದ್ದಾರೆ, ಅವರೇ ಒಂದು ಸಾಫ್ಟ್ವೇರ್ ಡೆವಲಪ್ಮೆಂಟ್ ಮಾಡ್ತಾರೆ ಅಷ್ಟೇ, ಇದು ಮಾಡಿ ದೆನ್ ದಿಲ್ ಕಮ್ ಅಂಡ್ ಪಿಚ್ ಅಂಡ್ ನಮ್ ಲೈಸೆನ್ಸ್ ಯೂಸ್ ಮಾಡಿ ಅದ್ ಮಾಡಿ ಅಂತ ಇದ್ ಮಾಡ್ತಾರೆ ಅಷ್ಟೇ. ಬಟ್ ಔಟ್ಕಮ್ ಎಷ್ಟು ಬರ್ತದೆ ಅದು ಗೊತ್ತಿರೋದಿಲ್ಲ, ಯಾಕಂತಂದ್ರೆ ಔಟ್ಕಮ್ ಅನಲೈಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಅಥವಾ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡ್ಲಿಕ್ಕೆ ನಮಗೆ ಗೊತ್ತಿರೋದಿಲ್ಲ, ಇಲ್ಲಿ ನಾಲೆಜ್ ಇರೋದಿಲ್ಲ. ಹ್ಮ್ 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 ಮತ್ತೆ ಇನ್ನೊಂದು ಅವರು ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ ತಗೊಂಡ್ ಮಾಡಿರ್ತಾರೆ ಅವರು. ನಮ್ಮ ಟೈಪ್ ಅದೇನೋ ಈಗ ಹೇಗನೆ ಎಫ್ ಎ ತಗೊಂಡಂತಾರೆ, ಸಿಂಪಲ್ ಇದು ಪ್ಲೇಟ್ ವಿತ್ ಹೋಲ್ ಅಥವಾ ಸಿಂಪಲ್ ಕಾಮೆಂಟ್ ತಗೊಂಡ್ ಮಾಡ್ತಾರೆ ಅವರು. ಕಾಂಪ್ಲೆಕ್ಸ್ ಫಿಸಿಕ್ಸ್. ಹ್ಮ್ 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 ಹಾ ಹ್ಮ್ 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 ಹ ಯಾವುದು? ಆನ್ಸಿಸ್ ಅಂಡ್ ಸಿಮನ್ಸ್ ಟೇಕ್ಔಟ್ ಮಾಡಿದ್ದಾರೆ. ಹ್ಮ್ ಸಾರಿ ಸಾರಿ ಆಲ್ಟರ್, ಇದು ಇವರು ಆನ್ಸಿಸ್ ಅಂಡ್ ಸಿನಾಪ್ಸಿಸ್ ಅಂತ ಹೇಳಿ. ಸಿಮನ್ಸ್ ನೋಡ್ ಚೆನ್ನಾಗಿದೆ ಆಕ್ಚುಲಿ. ಹ್ಮ್ ಲೈವ್ ಅಲ್ಲಿ ಯಾರೋ ಒನ್ ಪರ್ಸನ್ ಇದ್ದಾರೆ, ಗೊತ್ತಿಲ್ಲ. ಯೂಟ್ಯೂಬ್ ಲೈವ್ ಆನ್ ಮಾಡಿದೆ ನಾನು, ಚೆಕ್ ಮಾಡ್ತಾ ಇದ್ದಾನೆ ಅಲ್ಲಿ ಇವಾಗ ಕೇಳ್ತದೆ ಆಡಿಯೋ ಅಂತೇಳಿ. ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಕಾಣ್ತಾ ಉಂಟಾ? ಶೇರ್ ಮಾಡ್ತಿದ್ದೇನೆ ಸ್ಕ್ರೀನ್. ವಾಯ್ಸ್
ಬರ್ತಾ ಇಲ್ಲ.
ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ವಾ? ಆಪ್ಷನ್ ಕೊಟ್ಟಿದ್ದೇನೆ ನಾನು, ಎಡಿಟ್. ಹಲೋ, ಬರ್ದಿಲ್ಲ? ಬರ್ತಾ ಉಂಟಲ್ಲ ವಾಯ್ಸ್ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ? ನನ್ನ ಮಾತ್ರ ಬರ್ತದೆ. ಅದೇ ಯೂಟ್ಯೂಬ್ ಇದು ಅದೊಂದು ಪ್ರಾಬ್ಲಮ್. ಹ್ಮ್.
ಯಾರು ಪ್ರದೀಪ?
ಅಲ್ಲ, ಸಂದೀಪ್ ಅಂತೇಳಿ. ಕೇಳ್ ಕೇಳ್ತಾ ಇಲ್ವಾ? ಹಾ ಹಾ. ಹ್ಮ್. ಬಂದೆ, ಒಂದ್ ನಿಮಿಷ. ಇದು ಇಂಡಿಯಾದ ಏನಾದ್ರು ಇದಾಗೋ ಚಾನ್ಸ್ ಉಂಟಾ? Hello, Randeep. Hello. Ma- oh, chat ಆಗ್ತದಲ್ಲ. Okay, okay. Shall we start? ಸ್ಟಾರ್ಟ್ ಮಾಡೋದಲ್ಲ ಹಾಗಾದ್ರೆ ಬಾಕಿ ಅವ್ರಿಗೆ ವೇಟಿಂಗ್ ಮಾಡಿದ್ರೆ ಮತ್ತೆ ನಮ್ದು ಟೈಮ್ ಹೋಗ್ತದೆ. ಇಲ್ಲ, ಯಾರು ಮಾಡ್ಲಿಲ್ಲ.
ಮಾಡಿದ್ರೆ ಓಕೆ.
ಹ್ಮ್. ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಕಾಣ್ತದಲ್ಲ.
ಚೆಕ್ ಮಾಡ್ತಾನೆ. ಹ್ಮ್.
ಓಕೆ. Okay. So last week we had discussed on certain parameters on mean, median, mode. So I think just a recap, we had gone through uh, like what exactly was data and what are the different case studies. Okay, I think we had even solved certain problems and tried to understand what are the different, like say, kind of parameters or definitions where we are able to understand what exactly the data is, or how to understand the data behavior. And later on in last week we understand like understood even certain parameters which are required to like say describe this particular data or understand the behavior of the data. So basically they are nothing but mean, median, and mode. Okay, so they are called as measures of central tendency. When we say mean, it is more of averaging of a particular data. So we'll try to understand by taking an example. Already, like last week, also I have explained using an example, but here we'll try to do more intuitively, where I'll try to give a problem and we'll try to solve it. Okay. So what exactly is median and mode and range, variance, and standard deviation? So let's take an example of a bolt where the diameter is being measured. Okay. Or even the shaft, like in this case, I've given it as a shaft, but even for the bolt, we can do generally in production or QC stations, they try to measure the bolt diameter or even the shaft diameters. So we can take an example of shaft where I have like this particular data of the diameters, and now we can try to understand what are these different parameters of statistics which will help us to understand this particular data. So as I have said, mean is nothing but average of the data. So we have these many diameters. So as per the definition of mean, it is like total summation of that particular those data or the value individual diameter values divided by the count of the number of data. Like in this case, it is having 10 measurements of 10 different shaft diameters. So the value will be 10, and this is the summation of individual diameter of the shaft. So that will give the mean value, saying that approximately 25.003 mm is the mean diameter of the 10 shafts. Next, coming to median, here what we'll have to do is we'll have to sort the data first in the ascending order before calculating the median. Okay, so median is nothing but it's more of a middle value of the entire data set. So first you sort it. So once you sort that, then you try to take the middle value of that. Okay, so that would be in this case is 25.00 and 25.01. The reason is because it is even number, even number of data. Suppose if it is odd number of data sets, then you will have to take the average of those like middle value. Like in this case, it would be if it is 11 data, then it will be fifth and sixth data. You need to add and divide. So that is the median value. Next, coming to mode, it is like how many times the like kind of the frequency of a particular data. Or yes, Ajay, any doubts?
Yeah, I think median also comes in a way that if it's 10 people, 10 balls are there. So
Hmm?
median of it might be a median of n or median of it might be values also. Both can be possible, right?
Yeah, yeah, both
If
are
the
possible.
median of yeah, okay,
Generally, like say, if we have n number of data, it is like n will be a count to identify that median. Like
okay,
as you said, first
got
we'll
it.
have to identify what is the, like say in this case 10, we
Mm,
can take 5 plus 6, right?
mm,
So
mm,
that will hold as per your explanation, like first explanation, that first we need to identify what is the
correct.
median of the 10. Then that will help us
Mm,
to determine in these values what is the median of that.
mm, correct,
Yeah. But for odd, you'll get it directly, odd numbers.
correct.
Yeah. So I think we don't have much of a repetitive value, but here, what does that mean is like how many times a single value occurs.
Mm,
Okay, that is more of mode. And when it comes to range, it is like more of max minus min. That will give you a range. So in this data, we'll identify what is the max value and min value, and that will give a range of, like say, if it's a shaft diameter, what is the range of that shaft diameter? I think this will be very much useful in case of interference fits. When we try to design interference fit, and we try to give a tolerances, so we can give max tolerance and min tolerance, which will help us to design for min interference case or max interference case in case of shaft interference fit. Like we take example of uh, axle with the bearing, something like that. Then while designing the interference fit, it will be very much useful for us, like to decide the tolerances. Next comes the variance. Okay, so this is more applicable to understand the spread of the particular data. Like we have the data now here, but how this data is spreaded over the particular, like say, domain, or this kind of behavior, to represent the behavior. How is the spread? So for variance, what we do is we calculate the individual value. Like say in this case, it is 25.01 minus the average of that value, that is the mean, divided by the total count minus 1. Okay, so that will give some value for us. Now the square root of that value will give us the standard deviation. So what does that mean is how is it varying from the mean value, or how much is the spread from the mean value? That is the standard deviation. Like in this case, each value with respect to the mean, it represents the deviation of a single value with respect to the mean. So we calculate it individually. Then we can calculate the standard deviation when we add these things. Okay. So this is not much of importance, but coefficient of variation is like more of a percentage of that. By how much percentage is it varying? So now for this example, what we are able to understand is, like say, as I said, mean diameter is 25.003. So what does that signify in practical sense is, it means that it is extremely close to the expected manufacturing diameter value. Like when I try to, as I said, design for interference fit for say 25 mm, then 0.003, if it is having a mean diameter of 0.003, it means that it might be well within the tolerance limit what I'm trying to give. And the very low standard deviation means that it is well within the tolerance. So that signifies the physical meaning. So range would help us to give the when we design a shaft or even a bolt. And suppose if I have multiple many times, that's the mode. It means that most of the, like say, manufactured shaft diameter is within, it's kind of consistently getting measured with the same tolerance value. Or it might even give a cluster of data which might be useful later in machine learning, which might be, like say, it might have a similar surface finish or a similar machining procedure, and it might create a cluster of data which is having similar data value. Okay. So overall, what does this represent? It represents that there is very small variation with a very good precision in manufacturing. So that's what we can infer from this particular current data. But it will also help us to understand whether there is too much deviation or not. Okay, that's when a concept called as outlier comes in. If there is a if there is too much of deviation, yes, Ajay.
Yeah. What is the use of variance? Because standard deviation will understand how much it's
Yeah.
deviating from
That's
the
what.
mean. What
So
variance will understand
variance
from that?
is nothing but same thing. It's just square root of that.
Okay, okay. That's it's just, I mean, the term
Yeah, term.
used to, yeah, just for squaring of.
Hmm. Anudeep, do you like to add something to that?
I think voice is
Yeah, he's
not.
having a voice issue.
Mm,
Let me
mm,
see. I think he might be having. Okay,
mm.
he was typing something. Okay, by the time he types, we'll just go up with other concepts. So as I said here, now we are able to see this visually. Okay, now since I showed the data, we can see for each and every data it has created a bin. It's more of a histogram plot, and we can see what is the count. Like say there are two, like say shaft with 24.94, so it represents a frequency of 2. Okay, so that's more of a mode. And what is the mean value of that? Mean value of that is 25.002 out of this entire data set, and median is somewhere nearby to that. Okay, it
Mm.
can be even seen in box plot. So box plot, this
Correct.
represents the domain and it shows the mean is somewhere here. Now suppose I try to add some very high value. Okay, I think I'll just show it in terms of code. Okay, so we have a mean and median here, right? Let me just add a little bit very high data. Okay, so we have 24.93. We'll just put some very high data. So you can see outlier it is highlighting. This is a very much higher outlier. It's showing that the diameter is 100 mm. So you can see mean is shifted automatically to 28, but
Mm-hmm.
median is 25.010. Okay, what we have seen is 25.005. So median is very much sensitive, less sensitive to I mean, abrupt data or a kind of outlier. But mean is very much sensitive for that. We can see that, right? Mean it has shifted very much high comparatively,
Mm.
28.949. Okay, whereas median it is 25.010, which is very less deviation. So we can say that median is very much less sensitive for outliers or something like say out of box or not out of box exactly, but more of different data when it comes in a process, similar process. Let us try again a little bit similar data. Okay, we'll put 26 comma 26.03 comma 26.28, something like that. Okay, we'll just check it again. So now again we can see I just added a little bit more data, right? Nearby 26.
Mm-hmm.
So we are able to see there is a little bit outlier. Now the mean got again nearby to the original value, somewhere nearby, right?
Mm-hmm.
So this sensitivity we can see, whereas 25.010, it is not much sensitive. So we can see it even in terms of box plot. So outliers are clearly visible here in box plot.
Yeah. So outliers is like it's kept in that way to be outside the box. I mean, we have to separately code for that, or how it is.
No. See, this is when we represent the data. Okay.
Mm-hmm.
And when you put the box plot, it will automatically put the data over there.
Oh, okay. Mhm.
Okay. The reason is because see, if I take this mean and median line outside, it will just put this
Mm.
block here.
Correct,
This is
correct,
a
correct.
additional code which I have put it as a line graph saying that from the
Mm.
calculated mean value, put this line.
Correct,
But
correct.
when it comes to box plot is able to identify that it is
Mm-hmm.
going away from the limit.
Correct,
In
correct.
the coding only, we can put that here. Like
Mm.
we find upper bound, and these are a little bit like say next concept where we speak about percentiles, intervals, all those stuffs,
Mm-hmm.
right? So when we add this as a bounding box or bounding limits, I have put it as
Mm-hmm.
a limit here. Okay,
Mm-hmm.
that's how I'm able to define that as outlier here.
Oh, okay, okay.
Okay, suppose if I change this outlier, let's say I put it this as 3.
Mm-hmm.
In certain cases, based on domain knowledge, we'll have to change this. But standard is 1.5 times the upper limit and lower limit. Okay.
Mm,
So if I change this, see, it is somewhere here. I think it should
mm.
change. Okay, it is not changed. It is very high. Okay, still I think it's within the limit, even though it is not changed.
So it's like it should be whatever the max value and mean value outside that should be the outlier, right? Outlier, or like you
No,
won't take
that's what
that way.
max and min. We take it from that, right? Like say in IQR calculation, what we do is basically we calculate the limits, like percentage quartile of that.
Mm-hmm.
So like that, as I said first, this is a little bit advanced concept.
Mm-hmm.
So when we try to address this, I'll speak about
Okay,
outlier in
sure,
depth.
sure.
Yeah.
Mm,
As of now, why I have shown this outlier is because we'll
correct.
be able to understand the sensitivity of the mean, how mean
Mm,
affects that particular distribution plot.
mm,
Okay. So like I think we have understood what exactly these parameters mean individually. Okay. And how we are able to understand or kind of conclude or give the inference based on these statistical parameters. Right. The kind of how stable the procedure is, or the manufacturing QC station is, or if it is applicable for say sensor data or vibration data, how stable the vibration data is, or whether the same frequency is getting repeated, or is it in terms of harmonics. All these things can be measured using these parameters.
mm, mm,
Next, coming to other concept, we something have called as skewness. So this will help us to understand, like as of now we have just seen that we have some data which is distributed into different slots or bins, or even with
mm,
respect to individual diameters, and
mm.
how many components or how many pieces of shaft is having that particular repeatability. Okay, but how do we understand this again in terms of spread? Okay, so this is more of a spread of the data with the particular range. But can we still more define this spread or bifurcate or describe this spread better? So that's when a term called as skewness comes into picture. So what does skewness mean is nothing but it tries to describe the spread with some behavior. Kind of, it says that is a measure of asymmetry. In this case, we can see it is like little bit not exactly symmetric, but somewhat symmetric, as mean and median are very much nearby. But here, do we see any pattern? No, right? There is no pattern at all here.
Mm, yeah,
So
yeah, correct.
yeah, okay. So here again, I have other one use case. Okay, where we have some data. Let's say example of again the shaft. Okay, so shaft, it's having this is a healthy shaft which is operating with the normal condition, and there is some behavior with the some defect. Okay, and there is other one crack kind of a behavior in the shaft. Okay, again it creates some data. So here you can see how the data is getting distributed here. When this data here, and it is having a particular range where it is getting like kind of operated. The let's say amplitude is varying between -2 to 2 for vibration. Okay, and here we can consider these 2 points as outliers, but it is operating at that, even at that outlier point it might be possible that there's a critical rpm at that particular amplitude, like say roughly maybe around -3 to +3 or 3.5. It might be a critical rpm. That's why we have very single data or single bin data which might show like the outlier behavior. But the behavior of skewness, it represents the deviation from the normal behavior of normal distribution. So this means that there is some defect in that. Now here the frequency, yeah,
So also in this case, when you see as a outlier, so we have to check that whether that outlier will going to affect or not. So
yeah,
we
yeah,
might have to check by removing that. Is it going to
yes,
affect the, especially in the case of vibration, maybe, right?
yeah, that is true. But removing and this thing, it is not feasible. Let's see, it is feasible only
Mm,
when you are trying to do some parametric study or DOA study. Try to understand the
correct,
influence on
correct.
the, yeah. But in real case, if some crack occurs, then it is it's not possible. But if
Correct.
you intend to put some crack while testing,
Mm,
then as you said, it is easy to like understand the behavior. Okay, with the crack over at certain regions, how will the data get affected, or how will the behavior of the particular shaft will be
mm,
responding.
mm.
So it can be intentionally implemented to understand the behavior, or but in real case it happens that it is always like we don't know what will happen, right?
Correct, correct. Yeah.
So that's where it is easy to understand, okay, we have some normal data when it is healthy, and if some problem occurs there will be a shift in the data or change in the data pattern behavior, and then we might have to do a root cause analysis for that.
Mm, mm,
But if you are intentionally putting some crack or creating some defect for the healthy data and then trying to measure the data, then you know for what intention of defect, what is the data pattern behavior. It is more like a kind of say fail safe behavior. I mean, you already know what kind of defect might occur
mm,
because you have already studied it.
mm.
Both approaches
Correct.
can be taken care. I mean, taken
Mm.
actually. So one more point. Yeah, as I said here, when mean is greater than median and it is greater than mode, it will be right skewed. Okay, I think here in code it is wrong. Both are representing on
Old.
left side.
Yeah.
Yeah,
Left
yeah.
side.
So yeah, so it is wrong. I think I had to code it correctly. It's somewhere here. We try to do that. Okay, because of it's just because of the data what is created in random seed. So randomly, I just try to create the data and it is causing that problem. We'll just see if it is possible to. Let's see. Okay, still the data is not changing. We'll see. So, but
Okay.
less skewness is opposite of that.
Mm.
Okay. So what does that mean is when mean is greater than median or mode, it is right skewed, and when mean is less than median and mode is left skewed. So that we can see it here only. When these two values matrix changes,
Mm.
then that particular skewness reflects over there. When mean is equal to median is equal to mode, it is almost like everything falls in the same line
Mid,
and it
mid,
forms a normal distribution. Yes.
mid plane.
Yeah. So now, as we said here, mean, median, and mode. Uh, Here, one important point is we need to understand. Like last class, we discussed about discrete data and continuous data, right? If you
Yeah,
remember,
right.
yeah.
Correct, correct.
So, does mode get applied to discrete data or continuous data? Median and mode, sorry, median and mean, we can apply for discrete data also. So, what does
Correct, correct.
discrete mean? You know, right? Like I said, we can put
Yeah,
it
yeah.
into different bins.
Yes.
When we say a temperature measurement, if it keeps on continuously increasing or vibration data, it is more of continuous data. But if I put it into a certain bin, then it's more of a discrete data. So as we have seen here, we can calculate median and mode for that, right?
Mm,
So even for discrete data, we are able to calculate the mode.
mm, mm.
But is it possible for the continuous data?
Continuous data. Maybe not.
And if not, what might be the probable reason?
The data might be lesser in order to, create that.
No, continuous data has more data, right? Because you're like
Mm-hmm.
let's say you are having some mobile, and in
Mm-hmm.
accelerometer you just keep on measuring,
Correct.
or your health tracker. When you keep on
Mm-hmm.
running, we have the apps
Mm-hmm.
for fitness, right?
Correct.
So it's a continuous data.
Mm-hmm.
So you have a lot of data.
Correct, correct. Okay, got it.
So why mode may not be applicable for continuous data?
Yeah, Abhinandan, I am back. I
Yeah,
think
yeah.
some issue was with the Teams update. I
Okay,
updated.
you're back at right moment, I guess.
Yeah, maybe I can answer this.
Yeah.
Actually, if you see this continuous data, no, like
Hmm.
1 point, let's say between 1 and 2, we may have one number like 1.23456 7,
Hmm.
something like
Yeah.
after a point. We may have any number of decimals, right?
Yes. Yes.
Mm-hmm.
Yeah.
So that might be the reason.
Yeah. That is the reason. Yes, actually. So it works for discrete data, not for continuous, because continuous data can take on any value within that range.
Mm-hmm.
Probability of occurrence of a single value, like same value occurring, like as Anudeep said, suppose if you get down the decimals to, like say, one value or two value, like say
Mm-hmm.
23.2, 23.23, something like
Mm-hmm.
that, because of rounding off, then mode might be applicable for continuous data. But if you are
Mm-hmm.
taking for the precision, then it is very, very rare. It even depends on the domain knowledge or domain application, that mode may not work for that. That's when we have some alternate methods called as KD or histograms or something like that. So this histogram will help us to put it in a bin and understand that behavior of the continuous data. Like in this case, vibration data. Suppose if I didn't have histogram, it is very difficult for me to understand that behavior. Because of this histogram plot, I'm able to see a visualization of the continuous data in form of a normal distribution. So alternate for mode, we'll be able to plot it using histogram or KD, or there will be even certain other methods. So density function, again, it is based on probability. This is based on probability. I think we'll discuss on this in detail in upcoming classes, where different measures, how we can, like say, visualize that in graph and all those stuffs.
Okay, so I have a doubt. So
Hmm.
mode works for discrete data and not for continuous data.
Hmm.
Can we again repeat on that?
Yeah. So as I said, discrete data. What do we mean by discrete data and continuous data? Like, let's say I do a vibration measurement, or not vibration. Let's say,
Tracker only we can.
yeah, let's say temperature measurement. Okay.
Hmm.
I think I'll just take an example if I have it in my web. Somewhere here. Oh yeah. So suppose, let's say we have a machine here. Okay, you try to measure some temperature here, right? And now, let's say I don't have any graph here.